The way this works in a real laboratory is that the standards are purchased at 2,000 parts per million. They come in a mix, so that they come purchased and diluted to 2,000 parts per million, but they're mixed, they're separated such that they will be stable in the mix. They're not stable when they're mixed together, but they're separated and put in groups that will be stable together. Like, for example, the benzidine is typically separated all by itself. The phenols will all be together. The PAHs will all be together. The mix consists of 5 very small break-off vials. The 5 vials together form the 8270 calibration curve. The way this starts out is that the analyst gets the 5 break-off vials and carefully labels 5 autosampler vials. The autosampler vials, the most important label is the primary control number to go into the log for the EPA. This is EPA mandated, and everything has to be documented. So the first thing you do is document the standards for the EPA. They're given an ascension number on the jar and then an ascension number in a book. And so they would have ascension number and then maybe a label for what it is and maybe not, and then the description goes into the book. So the vials are broken off, transferred into the appropriate vial. So the first one's broken off, transferred, second one's broken off, transferred, third one's broken off, transferred, fourth one's broken off, transferred, fifth one's broken off, transferred. It has to be done such that they don't get contaminated. We have these 5 standards. We want to dilute them down to make a calibration curve. And we want them to have a 0.5 ml total. So remember, we picked the 25 mils. We said, well, let's make 25 mils. This is like, has to be a 0.5 ml. So we want a 0.5 ml of these guys mixed together for 20. We want a 0.5 ml of these guys mixed together for a 50, 0.5 ml mixed together for an 80, 0.5 ml mixed together for a 120, and a 0.5 ml mixed together for a 160. So how are we going to do this? Let's start with our 20. Because we want to make a 20 standard, and we want a 0.5 ml total, and we want to put it in one of these. Okay, we want a 20 standard. We want a 20 standard. And we want it made, these guys diluted all appropriately such that it comes out as 20 parts per million. These are at 2,000 parts per million. We want a 20 parts per million standard. We want to dilute these 5 guys down equally so that when we're done, we'll have 20 parts per million and a 0.5 ml total. Okay, this is how it works. Concentration times volume is equal to concentration times volume. We want 0.5 mils as the final volume. We want 20 parts per million as the final concentration. We're starting out with 2,000 parts per million, and the volume is our variable. So we do the calculations, and we find that we want the volume to be 0.005 milliliters. 0.005 milliliters? 0.005 milliliters is 5 microliters. That's not a problem. We got a syringe that'll nicely do 5 microliters. So we put 5 microliters of this one in it, 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 and 5 microliters of this one in it. And we're done with that one. Okay, set that one aside. Okay, we need one that's 50 parts per million. So we want a vial that's 50 parts per million of each of these. 50 parts per million. And we want 0.5 milliliters when we're done. So let's take a look at this. Concentration times volume is equal to concentration times volume. Our final volume is 0.5 milliliters. Our final concentration is 50. Our initial concentration is 2,000. How much do we need to add? Well, we end up with 0.0125 milliliters. That's 12.5 microliters. It's not a problem. 12.5 microliters. We take this guy, put 12.5 microliters from this one, 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 12.5 microliters from this one in here, and we're done. Moving forward, we want to make an 80. Take a vial, label it. This also needs to go in their EPA standards control log incident. This needs to be logged in also. Label it as an 80. How much do we need? Well, same thing. Concentration times volume is equal to concentration times volume. 80 times 0.5 milliliters, concentration times volume. 2,000 parts per million. What's our volume going to be? Our volume is going to be 0.020, which is 20 microliters. So we put in 20 microliters of this, 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 and we're done. So going to the next one, we got 120, which is 30 microliters, so 30 microliters of each one. And our 160 is 40 microliters of each one. Okay, labeled and everything. So we end up with our 5 points. We've added each of the 5 to each of our 5 standards. So we're done with these. We cap these off real good, store them away somewhere where they're safe. They're expensive. And we have our 20, our 50, our 80, our 120, and our 160. These are all nicely labeled. They go in the our control log, incidentally, for the EPA. But we're not quite done with them, are we? The ones we need half a mil for each one. So the 160, we have added 200. We need to add 300 to it to dilute it up to 500 microliters. In theory, you could bring it up to volume at a half a mil. But in actual fact, you really can't do that. You need to just calculate it and add it. So we add 300 mils to this 160. We add 350 mils to the 120. We add 400 mils to the 80. We add 437 mils to the 50. And we add 475 mils to the 20. And then we're done. So let me give you a quick walkthrough on how to actually do this. The way this is actually done is, I think this is kind of an important, it's a trick, but it's not anything that's completely insurmountable. So starting from scratch, let me give it to you as a lab tech, as a veteran lab tech. Let me give you the technique you use. You get a solid displacement pipette. Let's start with the 20. Get a solid displacement pipette. Turn it so that it'll give you 5 microliters. You take the first one, draw 5 microliters, put it in the first vial, labeled of course. Go through a series of rinses. The rinses are dirty, not so dirty, clean, clean, super clean. So you go through and you're done with the first one. Take the second one. Take up 5 microliters. Add it. Go through the series of rinses. Take the next one. Add it. Go through the series of rinses. Take the next one. Add it. Go through the series of rinses. Take the last one. Add it. Go through the series of rinses. Okay, so this one's done. Take your 50. You want to dial the 50 to 12.5. Dial your solid displacement pipette to 50. Go 50. Go through your rinses. Go 50. Go through your series of rinses. 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 I like solid displacement pipettes because they're easy to clean. You can just reuse the same sleeve. Just clean it, which you really can't do very well. The alternative would be to use a disposable pipette tip. And then the way to add the methylene chloride to bring it up to volume at 0.5 is to get a pipette, automated adjustable pipette with 1 milliliter, dial in the first volume you want, air out the pipette. The methylene chloride is very volatile, and it'll tend to want to blow out of the pipette and mess up your volumes. So let it come to equilibrium. Let the pipette come to equilibrium, and then do the first one. Punch in your new number on the pipette. Do the second one. Punch in the new number. Do the third one. Punch in the number. Do the fourth one. Punch in the number. Do the fifth one. Punch in the number, and throw the pipette tip away. It's all methylene chloride, so you don't need to use a bunch of different tips. So we have our 5 points. We have our 20, 50, 80, 120, 160. We get some samples in to run. So we line them up to, we have a prep blank. It has a 0.5 ml in it. We have 3 samples. They each have a 0.5 ml in them. And we have a couple of spike samples, a couple of quality control samples. They each have a 0.5 ml in them. The 0.5 milliliter is extremely important. The 0.5 milliliter is not approximately a 0.5 milliliter. It's exactly a 0.5 milliliter. And you should be able to look across them and see that they all have the exact same volume. Exact same volume. It's not any great trick, but it's important to understand that it's very important that the volumes be right. Now, the last step is we take an internal standard. The internal standard comes at 4,000 parts per million, and we put 5 microliters in each one. So we put 5 microliters of internal standard in each one of them. Remember that the internal standard quantitation is based upon the ratio of the internal standard to the total volume. So the volume has to be exactly 0.5, and the internal standard has to be exactly 5 microliters. So be careful. This is a good time to be as careful as you can. And now, like next week, you need to make a continuing calibration standard at 50. Just follow the same directions. Take a vial, put in 12.5 microliters in each one, add 437.5 microliters to bring it up to 500, add 5 microliters exactly of the same internal standard, and you can hit the iCal every time if the other variables are correct. If your GC is working properly, you can hit the iCal every time. It's actually pretty satisfying. The initial calibration is complicated, but when it comes out, which it will if you're careful, it's cool.